Assalamualaikum and hi to all. Okay, basically in our previous class we having some trouble because there was our first class, and that's why it's quite hard for us to finish all together in one day for our module 1. And now in this video I'm going to continue our learning, which is still under module 1. Okay, previously we already looked into several subtopic under our introduction module 1, which is an overview, components of computer architectures and function. And now in this video we're going to look into computer evolutions. As mentioned in our class previously, for me myself it's quite bored, especially when we talk about history, but some of you might interested to learn history. That's why as mentioned also before we get to know something, of course we need to know the background, asal usul kejadian seseorang, right. The same goes to what we would need to know about computer, how basically computer start on the evolution. Okay, this is the historical development of computer evolutions. Yeah, it is maybe we can't we didn't see basically how the movements of a computer, but it's already started since the very beginning. And it is not supposedly we can call as a computer, but it is a calculator instead. Still, this is the first inventions of evolutions of computer, started since 1642. Quite long, I think. It is not my age, but of course it's already 200 years, not 400, yeah, around 400 to 500 years back then. And here is first thing on mechanical calculation machines. And for me myself, I think the first computer is on this one, which is starting the first gen of computer, which is called as vacuum tube computer. So that is after that transistor transistorized computer. But throughout we're going to compare and look deeper only on the first inventions. This is vacuum tube computer, and the evolution is no need for you to memorize each detail, when the vacuum tube computer invented, but mostly this is what you need to know about the movement evolutions of computer. And then it's moved to integrated circuit computer, a very large scale integration, VLSI. I think for those who are working in the industry, which is play around with computer and electronic things, you might hear this VLSI every single day, since also ULSI, which is ultra. Now today we go for ultra mini, so mini, tiny, and although it is very small, but it support, you can see over here, high in speeds. Okay, if you want to have sorry, not here. If you want to go more deeper, like you interested to learn more about the evolutions of this computer, you can also go and take a look all these extra notes. I think I already uploaded into the e-learning, so please take a look, okay? And now we go for the first and our first generations for von Neumann models. This is the earliest electronic computing machines programming with synchronized with connecting wired to plug. So you can see, this is the computer? I can't imagine. Maybe you can try to Google how von Neumann's models look like. Of course, I think it's going to be quite big, as previously. So all the things like including our telephone also big, and it's going to like small, and suddenly when you reach to ultra small, then nowadays, you're going to like, okay, I don't want to go for a small. I want to move to the biggers and biggers and biggers. So maybe back then we're going to have like super big computer, and that would be much expensive, which is everyone wants to buy it. Okay, the earliest electronic computer machines programming with synchronized with connecting wires to plug. No layer architecture exists. So programming a computer was as much a feat of electrical engineering as it was an exercise in algorithm design. Also, program computers have come to be known as von Neumann system, using the von Neumann architectures models. So you can like also have extra information from the resources I listed below here. And this Neumann model used the designing of building the first generation, which is vacuum tube computer. So sorry, it's quite like boring to learn history again. You can see there is a three following step for the three characteristic under vacuum tube computer. First is the computer consists of 4 main subsystem. Okay, this is the one that you need to know, okay, because it might also have the possibility question for test and final exam to ask you about the subsystem for under Neumann model. So you need to know it is memory, ALU, control unit, and also IO or input output. Second, you're going to have a program is stored in a memory during execution. And lastly, about under Neumann model, which is program instructions are executed sequentially. This is how the architecture of structure Neumann machines. So you can see that there is a main memory, and it will connect it to the CPU, which is our CPU, central processing unit, including the arithmetic logic unit CA, and also program control unit CC. And vice versa, there will be what is my microphone? There will be the input output equipment, which is like you might have like the keyboard and so on. I don't know whether is it look like a keyboard somewhere. Maybe this is a keyboard. I'm not going to go deeper because yeah, my personality, I did like history. Okay, go back to the slide. Okay, this is the uh, bottlenecks for the Vienna machines. You can see over here. So you need to have like a link together to your CPU. Conventional store program computers have undergone many incremental improvements over the years. These improvements include adding specialized buses, floating point units, and cache memory, to name only a few. Departure from the classic of Vienna architecture in non-Vienna models is the departure of the classic one. So that is on the first generation, which is the non-von Vienna model. What we can learn and what we can basically dig deeper in the non-von Vienna model, which is adding processors and parallel processing are examples of approaches in the non-von Vienna models. If you compare to this one, is the, you can see over here, going to put okay, this one is for von Vienna machines, but when you want to apply the non, it's adding the processor and parallel processing. I think at year 3 you're going to learn hash. You're going to have like a choice for you to pick the elective subject, and one of that is high performance data processing, or high performance HPPC, high performance parallel processing. Then you're going to look deeper on this thing, parallel processing. So now it's just a surface thing that you need to know. It is going to be applied in the non-von Vienna model. Adding a processor can increase computational throughputs. So this is like the advantages by adding the processor. And parallel computer improves speed by doing multiple tasks at one time. That's why in that HPPC subject, you're going to learn all of this, because our computer system nowadays are using a parallel processing, parallel computing, because we can speed our processing time. Let's say we open multiple application in one time, so then it's going to be like open it smoothly, because we will divide it into several tasks, which is like Microsoft Words go to like several tasks of processor. Will, let's say processor 1 will handle Microsoft Word, processor 2 will handle our, let's say we open Photoshop. So it's open parallelly and handled parallelly by the processor, and then it's going to be like very smooth. Okay, now this is the modified versions of von Neumann's architecture, which is after you adding a system bus. There is no just question, I guess so, similar to previous year. There is no question that asks you to like memorize all these things. Maybe they're going to give a picture, then they're going to make this empty, and you need to know what is this part. But instead of that, you need to know how basically they are connected together. CPU can connect to the main memory, input output through their own buses system. They cannot have like only one single connection of bus, and all the connections, let's say data, address, control, will be in one buses. No, they're going to like divided it, like CPU, if let's say whatever including data is going to be their own bus. So like data bus one, address bus, and then controls bus, then they are connected together to memories and input output as well. Okay, now we're going to dig deeper on processors. Last time when I was a student, I think I don't know basically about processor. When I want to buy a laptop at that time, I just was like, okay, whatever computer that expensive, I think it's going to be good. But throughout, it is depend on, maybe it is expensive because it is big screen, or maybe the what we can say that about this card display, what about the display things, which is going to take much more higher resolutions on the display. So maybe that because of that it's expensive. But yeah, that time I don't know basically about computers. So then I know now, whenever I want to buy a computer, first thing first, I'm going to look into what type of processors that available for specific computer. So mostly we're going to like take higher processors, and of course it's going to be more expensive. It's if it support very high speed performance for your computer. And then you can see over here, LED in 1916's high performance computer system were equipped with dual processor to increase computational throughput. In 1917, supercomputer systems were introduced with 32 processors. Then if you compare between like none or maybe one single processor, of course it like kura very slow. Supercomputer with 1000 processors are built in 1980s. How come we can have like 1000? It's quite mini, right? But it's already early on 1918s. It's already invented. In 1999, IBM announced its Blue Gen system containing 1 million. Oh, I hope that I have this amount of money, it's not processor. If I were what I can sell, if I were given the opportunity to have like 1 million processor, maybe I can like, okay, I'm going to sell this 1 million. At least what I can sell 1 ringgit per each processor, then add up, I'm going to get also 1 million ringgit Malaysia, right? Just kidding. Okay, now we're going to look into parallel processing. Before that, let me check. Wait, process. Okay, now you can see over here under parallel processing. Parallel processing is currently the most popular and the only method of providing increased computational power. Maybe next year there is another method. Who knows? More radical systems have reinvented the fundamental concept of computations. These advanced systems include genetic computers, quantum computers, and data flow systems. At this point, it is unclear whether any of these systems will provide the basic for the next generations of computer. Maybe I can like go through and speed up a bit so that we can finish early in one video and we like continues in our online class. I think so for like module 1 we can like having more time on videos, but if let's say in the technical terms, like when we are dealing with our assembly language, assembly processor, programming, then we need to be together online. Okay, under microprocessor, yeah, this is very small, tiny, cute electronic things, I guess so, but it is very powerful. Microprocessor, all CPU components in a single chip. So this is our CPU, our heart. If let's say there is something's happen, broken or whatever, burns, so it will might corrupt our computer as well. The more elements were placed on each chip, so that fewer chips were needed to construct a single computer processor. Early evolutions of Intel processor, whoever like work at Intel or maybe you have experience dealing with it, you might know about this. You can see last time it looked like this, very big. I think when I learned also on the processor, I can see this like IC. It's beginning from this pin 1, pin 2, pin 3, and then we need to calculate this pin and name it following the anti-clockwise, right? So there is like a pinch and a notch over here to start the pin number. So we need to start at here as a 1. So if let's say we are wrongly putting the like pin number, so we're going to get wrong in answer. So that is about the pin for the IC. So after that, it's like improve their looks and become a bit bigger, I think so, but it's going to be like slimmer. And lastly, I think you can like go through over here about all the ICs examples. There is a lot of ICs, but no need for you to like memorize everything. Just it's okay for you like to know all the chips and IC that available under Intel processor. So you're going to see, wow, now the looks become quite exclusive, slimmer and smaller. So if you like go back to here, I think if we compare to this now so the current Intel Titanium, it's very sleeky and yeah, quite smart. I prefer this look rather than this kind of version. So this is the evolutions of our processor. You can see that we have Pentium 2, Pentium 3. Until now today, we rarely see our computers or laptops having these processors anymore. Now we move to like core, dual core, 4 core, 5 core, whatever core, 7, right? I think the highest nowadays, and it's much more expensive. And that is the first thing you're going to look into when you want to buy a new computer or laptop. So for me myself, okay lah, nah, this is the one, Core 7 nowadays. Um, is it there is another one, another latest processor? I think no, but maybe when I want to buy a new laptop, I'm going to look into and do the research on this. You can see that uh, you're going to see like on the clock speed over here, it is 4 gigahertz compared to the oldest. I think my versions of my computers last time or laptop while I'm a student, I think only like Pentium, but I forgot which Pentium, but it is megahertz only compared to the 4 gigahertz nowadays. So that is about the computer evolutions. Now let's we move without any further delay on the computer level hierarchy, on the overview, and also the layers in virtual machines. Computer level hierarchy overview. You can see over here, you have a computer consists of many things beside chips. Before a computer can do anything worthwhile, it must also use software. I think I want to cut this video so that it's not going to be too long. I'm going to like spread another video for you to watch, just only for like subtopic and subtopic.